This is another RepublicNetworks.com YouTube podcast. This is a continuing series. We recommend, if you haven't seen the initial part of the series, part 1, which is the differences between routers, switches, hubs, and firewalls, which is a general overview. This is part 3 and is overview light. And it's part 3 continuing with this series. We do recommend you kind of view them in order. It gives you a much better idea of what we're talking about. And once again, it's light edition, meaning that we can't go in depth because we only have about 10 minutes or so to go over some general ideas and concepts that make up these network connected devices. This third part will be covering network switches. This module is part 3 of our series, and basically it's covering network switches, which in today's network infrastructure, switches make up a large majority of almost every network of every size, whether they be small, medium, large, and enterprise networks. There's a multitude of switch types which can be considered types of bridges as well. The idea is that almost all current networks have a large population of switches. Switches are mainly used in the connection of core infrastructure devices such as servers to endpoints, which could be clients or workstations inside of your organization, which will be represented here, which is your local area network or LAN. Basically the switch functions to connect all those devices, to share resources internally on your internal network, and also really combine those resources together and make them available for external resources, whether they be internet or clients or remote employees and all the different things that go along with it. So we'll basically start with really the basics, and some of these we did cover in the overview on part 1, and we're going to just hit them again here real quick. Basically, switches on the OSI model, which we'll cover on another module, operate on the layer 2 model, and basically they're MAC address based, media access control. This MAC address, similar to every person in the U.S., at least we hope so, has a social security number. A MAC address is basically a main identifier for a network connected device. So typically if a computer has one network interface card, that network interface card somewhere has a chip, and in it has a burned in or a permanent MAC address. Now you can spoof them. We'll go in that and other modules and how to identify those and how to mitigate that from a security perspective, and then from a penetration tester perspective we'll talk about why you may want to do that in testing networks. But a MAC address is similar to a social security number in that it specifically identifies network devices. Now it's an important note to remember as well that MAC addresses are manufacturer specific. A lot of people don't understand that. We'll have to show you an example, but basically MAC addresses, they are a series of numbers, and basically the first couple octets or pairs of numbers identify the manufacturer. So just by looking at numbers, whether you memorize them, which most don't, or you have a decoder tool like I do, you're able to actually identify, oh, that's a Broadcom network interface card, that's an Intel network interface card, that's a Cisco switch or device, which is really helpful in identifying just from a numerical basis without even having to see the equipment, which is good on logs and other places for switches. And we'll get into that in other modules, how to view logs and different things. But basically, as you can see here on the diagram with the network switch, it's connecting all these devices. They just happen to be workstations. They could be IP phones. They could be servers. They could be all kinds of different devices you see on your normal network. It's important to remember that when you first start up a switch, it doesn't really have any information. It has to learn information unless it's able to learn, and when it's unplugged, save that information, which some switches support that resiliency. But most switches actually operate, and what they do is they have a little table similar to the routers inside the switch itself, which is here. Similar to a table, but totally different actually than a router, and we'll explain the differences why. But basically the table is basically a MAC address table. And the MAC address table basically, when anything communicates for the first time, the switch doesn't have anything populated in this table. So it has, in this case, this one looks like it has 5 ports, and it has all kinds of different connected devices. Each of them have, let's just say for the sake of this conversation, one MAC address. Well, until this device communicates with the switch for the first time, the switch has no idea what it is. And so generally, whether that communication is initiated by a data request or it's done on an interval, which is basically an interval in which the machine, if you don't choose to communicate, the machine automatically comes out and tries to do a broadcast and possibly see where it's at. And in doing that communication, depending on the operating system that's providing that communication, whether it's Windows or Unix or whatever. Basically, for instance, Workstation 1, when it talks to this, in this case port 2, the switch actually populates port 2 with its MAC address. So the switch knows, hey, this computer is on port 2. Now, notice I said this computer communicated. So some communicate on an interval. If you don't do anything, they talk and speak and try to do some network discovery, and they do different things depending on the operating system you're working on. They talk without even you having to actually request data. The point I'm trying to make is, if you actually did request data before that interval happened, a second step would happen. First and foremost, Workstation 1 would talk to port 2. The switch would actually see, hey, there's a computer or a device with this MAC address, so it knows this computer's on port 2, and it maps that to port 2. So it just basically says to anything else on the switch, hey, just so you know, this computer's on port 2. In addition with that, because it's a data request, it's also going to have a destination. So it's important to know the destination could be Workstation 2, typically an IP address. And so there is other methods, but for the sake of this conversation. So for instance, the second step that happens is not only does the switch save that information from Workstation 1, but Workstation 2, it doesn't really know where it's at, because Workstation 2, let's just say for the sake of this conversation, hasn't engaged in this type of communication before. So similar to a network hub, a network switch actually broadcasts out on all ports basically information for the destination of the IP address, which in this case would be Workstation 2 for this example. So some people say, wow, it's just like a network hub. I don't understand. That doesn't make any sense. Well, the idea is that when it communicates with Workstation 2, there's a reply that's sent during that communication that lets the switch know, hey, not only is computer 1 on port 2, but computer 2 is on port 3. So as you can see, it's building what we call the MAC address table, but it's basically a mini database. Okay, so now what? The next thing that happens is that the next communication that occurs between Workstation 1 and Workstation 2 is actually the data flows to port 2, but because the switch knows where this device is at this time, which makes it so much different than a hub, it actually doesn't go through the broadcast phase because it already knows where Workstation 2 is. It's on port 3, as you can see here. So it transmits data only on this Ethernet cable to port 3, and obviously to the destination subsequently of Workstation 2. And none of these other network cables or connections get that communication because the switch has learned, and that's really the key concept of this layer 2 device. Layer 2 really is no IP addresses on the same network. We'll get into routing in a subsequent module and a further module. But the point is that this is all MAC address based, basically. So that's the idea and the explanation behind the basic network functionality of a switch. Most of the nicer, newer ones are managed, which means they have a unmanaged, which is basically plug and play. Or we call it plug and pray, which is basically you plug it up and hope everything works. We like more control as network administrators and engineers, and so we prefer managed devices. Managed devices they look exactly the same in most aspects, but basically managed devices, you can program it to meet your network needs. You can give it an IP address. It may even have a little web address where you can log in and view statistics on the ports of how much data is flowing. It might even give you a chance to create VLANs and other higher level network managed information, and we'll get into that in another module. But that's what basically a network switch, managed network switch is. It provides you the functionality to be able to possibly turn ports on and off remotely through a web page. It may even provide telnet access, which is a DOS-looking screen, and we'll show you an example in a further module. And really a multitude of information. There are switches that are out there that provide quite a bit of information via a web interface. Cisco provides several different tools, both standalone applications that communicate with Cisco devices, such as network switches. A lot of other switch manufacturers, including Cisco as well, do include a web-based option where you don't have to install software. You simply connect to the switch's IP interface, and you log in via port 80, which is a web interface, or 443 for secured. And the idea being the ease of management and also making that switch work for your particular application, for your particular. This switch alone, right, as an example, it looks like 6 ports. You may only have 3 devices in a small network, and you may, because of security reasons, want to turn the last 3 off. And this web interface allows you to be able to do that. And that's one of the great advantages of a managed switch. Although they cost more, they provide you more security, control, flexibility, and management when it comes to deploying switches in your situation. We'll get into STP or spanning tree protocol, really what that means and why as a managed switch it's